Hi guys, this is Miss Pruitt again, and I'm coming to you with another video about solving right triangles, because this is solving right triangles part 2. And these examples are if you are given only two sides. All right, so getting started with it. Make sure that you write down these 5 steps, because these are going to be the 5 steps that you will use every single time that you are solving a right triangle given two sides. Step 1, draw your triangle. Step 2, use the Pythagorean theorem. Step 3, we're going to use SOHCAHTOA or TOA, which means sine, cosine, or tangent. Step 4 will always be where we're going to take the inverse, and step 5 is going to be using the triangle sum theorem, which is that all of the interior angles inside of a triangle should add up to 180. So here's the example that we're going to work with, and this is if you are given two sides. Solve the right triangle if the only thing I tell you is that A equals 4.4 and C equals 11. If we are solving this right triangle, that means I'm going to know all 3 angles. So that would mean angle A, it's way too thick. Sorry guys. Angle A, angle B, and angle C. And also side A, side B, and side C. I'm plugging in what I know. All I know right now is that side A is 4.4 and side C is 11. So step 1 tells me to draw my triangle. So I'm going to draw my triangle right here. Doesn't matter which way that you want your triangle to face, as long as it is a right triangle. I tend to make this A, angle B, and angle C, and this side A, side C, side A, and side B. Okay, so we did step 1. Step 2 says do the Pythagorean theorem. Well, I know that this side is 4.4, and I know this side is 11. So Pythagorean theorem says a squared plus b squared equals c squared. And plugging in what I know that this is 4.4 squared plus b squared equals 11 squared. But I want that b by itself, b squared. So I'm going to subtract 4.4 squared from both sides. So this will be b squared equals 11 squared minus 4.4 squared. And I want this b by itself, so I'm going to take the square root of both sides. And if I plug the right-hand side into my calculator, I would get that side b is 10.08. So I'll put that up here, 10.08. Sorry about that. Okay. Step 3 says, let's use SOHCAHTOA. So if I'm going to be using SOHCAHTOA, that means we're either going to use sine, cosine, or tangent. And remember, SOHCAHTOA just helps us remember what side is what. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And at this point, it really doesn't matter which side we use, because we know the length of all 3 sides. So it doesn't matter. Let's just pick sine. Well, I know that sine theta is opposite over hypotenuse. And in this case, I say, hey, let's go ahead and let's just find angle B first. So I'm going to say that sine of angle B is going to be the side that is opposite of angle B. The side opposite of angle B is 10.08 divided by the hypotenuse, which is 11. But I don't just want sine of B. I just want B all by itself. So that means I have to come up with something or find something that will get rid of the sine. The only thing that's going to get rid of sine is going to be its inverse. Inverses cancel out original functions. So I am going to take the inverse of the left-hand side, but whatever you do to one side, you must also do to the other side. So the inverse sine of sine, well, these two will always cancel out. So that will leave me with angle B equals inverse sine of 10.08 divided by 11. If I put that in my calculator, it will give me that angle B is 66.4 degrees. All right, you guys, so I know that angle C is 90, angle B is 66.4 degrees, and the only thing that's left is to find angle A. So I need to use the triangle sum theorem. I'm just going to abbreviate it right here. Triangle sum theorem says angle A plus angle B, plus angle C equals 180 degrees. Well, I know what angle A and angle, what angle B and angle C are. I just need to find out what angle A is. I'll write the long way for you guys. I'm plugging in 66.4 degrees and I'm plugging in 90 degrees. And it equals 180. And I want to get that angle A by itself, so I need to subtract 66.4 degrees and 90 degrees from both sides. So angle A is going to equal 180 degrees minus 90 degrees minus 66.4 degrees. And I would get that angle A equals 23.6 degrees. And since I have, it's up too high. Since I have Since I have all three angles and all three sides, I have solved this right triangle. All right, so now it is your turn. Go ahead and pause the video and see if you can solve triangle A and triangle B using those 5 steps from the beginning of the video. So I'm definitely going to go a little bit faster on these 2 examples. Hopefully you guys did pause it and try to do them on your own. But I did first step, which is drawing a triangle. Second step is Pythagorean theorem. So in this case, c squared will equal 13 squared plus 8 squared. And then I take the square root of both sides. If you plug that in your calculator, you should have got that side C was 15.26. The next step is for us to use SOH, CA, or TOA. In this time, it doesn't matter. I just picked cosine. I know then that cosine, and I'm going to look for cosine of angle B. Well, that's going to be adjacent over the hypotenuse. And so that means that it is going to be 13 over 15.26. But I want to get rid of the cosine, so I'm going to take the inverse cosine. Whatever I do to one side, I need to do to the other side. And I plugged that in my calculator, and I got 31.58 degrees. Last step is the triangle sum theorem. So I take 180 and I subtract the angles that I know, which are 90 and 31.58. And I got that the missing angle, or angle A, was 58.42. So if you worked it out on your own and you got this, congratulations. You're going to get an 8 on the test. All right, you guys, moving it along. Part B, I already drew my triangle. I put down my knowns. That was step 1. Step 2 is Pythagorean theorem. So in this case, it will be a squared equals c squared minus b squared. And I know what c squared is. Oh, I didn't finish writing my unknowns. This is 30, my knowns. That's 33, and that's 26. So this would be 33 squared minus 26 squared, and then take the square root of that, of course, taking the square root of both sides. I would get that side A is 20.32. All right, so next we need to do So, ka or toa. I already did sine and I did cosine, so why not? Let's do tangent this time. So, and I tend to always find angle B first. It doesn't matter, you can use angle A. But tangent of B is going to be opposite, which is 26, over adjacent. So this is opposite of angle B. This is adjacent to, so this is going to be 20.32. And I want B by itself. So step 4 says we will always do the inverse. I'm going to do the inverse because I need to get rid of that tangent. But whatever I do to one side, I got to do it to the other. Those two cancel out. I plug in the inverse tangent of 26 divided by 20.32 in my calculator, and I get 51.99 degrees, which is approximately 52 degrees. Last step is using the triangle sum theorem. And the triangle sum theorem says that all of the angles should add up to 180. So I'm going to do 180, I'm going to subtract 90, and I'm going to subtract 52 degrees. And if I plug that to my calculator, I would find that my missing angle, which is angle A, is 38 degrees. So if you also got this one correct, good job, and you're going to make an A on that test. And that's the end, and I hope this helped you guys.